Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. And make sure to stick to the end of the problem, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have 2 to the power of x is equal to 20 to the power of 8. Now, the first thing I'm going to do is I'm going to take the log on both sides. So now I have log 2 to the power of x is equal to log 20 to the power of 8. Now, an important property of logarithms is that if I have something in the form log a to the power of b, I can actually move this exponent b to the front of the logarithm. So this would be equal to b times log a. So in this case, for both log 2 to the power of x and log 20 to the power of 8, I'm going to be using this property. So for log 2 to the power of x, I'm going to move the x to the front, and log 20 to the power of 8, I'm going to move the 8 to the front. So now I have x times log 2 is equal to 8 times log 20. Now, what I'm going to do is I'm going to divide both sides by log 2. So then these two cancel out, and I'm left with x is equal to 8 times log 20 over log 2. Now, if I have something in the form log AB, this is equal to log A plus log B. So in this case, 20, we could rewrite as log 10 times 2. So this would be equal to log 10 plus log 2. So now I have x is equal to 8 times log 10 plus log 2. Now I have this over log 2. Now log 10 is simply equal to 1. So now I have x is equal to 8 times 1 plus log 2 over log 2. Now this is the same thing as 8 times 1 over log 2 plus log 2 over log 2. And log 2 over log 2, these two simply cancel out. So I'm left with x is equal to 8 times 1 over log 2 plus 1. Now, if I distribute the 8 to both terms, I get x is equal to 8 times 1 over log 2 is 8 over log 2 plus 8 times 1 is 8. Now, log 2, this is equal to approximately 0.301. So I have this plus 8, and now 8 over 0.301, that's going to equal 26.57 plus 8. So my final answer is 34.57. All right, so I have 3 to the power of x squared plus 2 is equal to 27 to the power of x. Now, the first thing I'm going to do is I'm going to change 27 here to 3 to the power of 3, because 27 is equal to 3 to the power of 3. So if I substitute in 3 to the power of 3 for 27, I get 3 to the power of x squared plus 2 is equal to 3 to the power of 3 to the power of x. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of 3 to the power of x, that's going to equal 3 to the power of 3 times x, also written as 3 to the power of 3x. Now, if I have something in the form a to the power of m is equal to a to the power of n, then this means that m is equal to n. So in this case, x squared plus 2 is equal to 3x. Now to solve this, I'm going to subtract 3x on both sides. So now I have x squared plus 2, x squared minus 3x plus 2 is equal to 0. Now I have a quadratic equation. And to solve this, I'm going to be using the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is equal to 1, b is equal to negative 3, and c is equal to 2. So I have x is equal to negative 3 plus or minus the square root of b squared, so negative 3 squared minus 4 times a, which is 1, times c, which is 2. Now I have this all over 2a, so 2 times 1. Now to simplify, negative of negative is positive, so negative 3 is positive 3, plus or minus the square root of negative 3 squared. Negative times negative is positive, so negative 3 times negative 3 is positive 9, minus 4 times 1 is 4, 4 times 2 is 8. Now I have this all over 2 times 1, which is 2. Now I have x is equal to 3 plus or minus the square root of 1, 9 minus 8 is 1, over 2. Now I have x is equal to 3 plus or minus 1 over 2, because the square root of 1 is 1. Now this gives me two equations. I have 3 plus 1 over 2, and I also have 3 minus 1 over 2. So for 3 plus 1 over 2, this is equal to 4 over 2, which is simply equal to 2. For 3 minus 1 over 2, this is equal to 2 over 2, which is equal to 1. So 2 and 1 are my values for x. Now to check, started with 3 to the power of x squared plus 2 is equal to 27 to the power of x. Let's first try x is equal to 1. So if x is equal to 1, now I have 3 to the power of 1 squared plus 2 is equal to 27 to the power of 1. 1 squared is 1, so now I have 3 to the power of 1 plus 2 is equal to 27. 1 plus 2 is 3, so I have 3 to the power of 3 is equal to 27, and 3 to the power of 3 is 27, so I have 27 is equal to 27. This is right. Now let's try 2. X is equal to 2. So now I have 3 to the power of 2 squared plus 2 is equal to 27 to the power of 2. Now 2 squared is 4, so I have 3 to the power of 4 plus 2 is equal to 27 to the power of 2. Now 4 plus 2, that is going to equal 6. So now I have 3 to the power of 6 is equal to 27 to the power of 2. Now 27 to the power of 2, that is going to equal 729. And 3 to the power of 6, this is also 729. So I have 729 equals 729, so x equals 2 is also a solution. So I have x to the power of x to the power of 5 is equal to 100. Now the first thing I'm going to do is I'm going to take the power of 5 on both sides. So now I have x to the power of x to the power of 5 to the power of 5 is equal to 100 to the power of 5. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So in this case, I have x to the power of x to the power of 5 to the power of 5, and we can think of m as x to the power of 5 in this case, and n as simply 5. So, and also we can think of a as obviously x. So this would be the same thing as a to the power of m times n. So in this case, x to the power of 5 times 5. And now this is equal to 100 to the power of 5. Now, if I have something in the form a to the power of m times n, this can be written as a to the power of m to the power of n, right? Well, a to the power of m times n, this is also the same thing as a to the power of n times m, meaning a to the power of n times m, this is probably equal to a to the power of n to the power of m. But because both of these two things are equal to each other, then this means that these two are the same thing as well. Meaning, if I have something in the form a to the power of m to the power of n, I can also write this as a to the power of n to the power of m. So in this case, I have x to the power of x to the power of 5 times 5, and I'm going to rewrite this as x to the power of 5 to the power of x to the power of 5. And now this is equal to 100 to the power of 5. So now 100 here, this is equal to 10 squared. So now I have x to the power of 5 to the power of x to the power of 5 is equal to 10 squared to the power of 5. And now if I have something in the form a to the power of m to the power of n, remember this is equal to a to the power of m times n, so I'm going to be using this property for 10 to the power of 2 to the power of 5, so meaning this would equal 10 to the power of 2 times 5. And 2 times 5 is simply 10, so now I have x to the power of 5 to the power of x to the power of 5 is equal to 10 to the power of 10. Now, if I have something in the form a to the power of a is equal to b to the power of b, then this means that a is equal to b. So in this case, x to the power of 5 is equal to 10. Now to solve this, I'm going to be taking the fifth root on both sides. So then these two cancel out, and I'm left with x is equal to the fifth root of 10. Alright, so in this video, I'm going to be solving the problem 9 to the power of 10 plus 9 to the power of 10 plus 9 to the power of 10. And for this problem, I actually have 4 option choices. So for A, I have 27 to the power of 30. For B, I have 9 to the power of 30. For C, I have 27 to the power of 10. And for D, I have 3 to the power of 21. So to first start out, let's go through all these option choices and see if they're right or not. So we first have A 27 to the power of 30, and how this likely was resulted in was from adding all the bases and adding all the exponents. So we have 9 plus 9 plus 9 to the power of 10 plus 10 plus 10, which is equal to 27 to the power of 30. And this is actually wrong because this is not the proper way to add exponents. So now going from here, this was likely gotten, 9 to the power of 30, by keeping the base the same and then adding the exponents. And this again is wrong because this is not the right way to add exponents. Now we have 27 to the power of 10, and this was gotten from adding the bases but keeping the exponent the same. And this again is wrong as well. That's not how you add exponents. Now 3 to the power of 21, which is by process of elimination the right answer, we're going to see how they got this. So we first start with 9 to the power of 10 plus 9 to the power of 10 plus 9 to the power of 10. And I'm going to factor out 9 to the power of 10. So I get 9 to the power of 10 times 1 plus 1 plus 1, which is equal to 9 to the power of 10 times 3. And now this is equal to 3 squared to the power of 10 times 3. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of 2 to the power of 10 is going to equal 3 to the power of 20. And I have this times 3 to the power of 1. So I simply just add the exponents. This is equal to 3 to the power of 21. Now, if you haven't already, please make sure to subscribe, leave a like, and share this to any of your friends or family members.